Hello everyone, and welcome to our discussion to CSCI 25, Introduction to Programming in Database. For this session, we are going to be learning about SQL subqueries as well as window functions. For this session, we are going to be discussing the following topics. First are derived tables, second are common table expressions, and afterwards we are going to be having an activity for these particular subqueries. And next, we are going to be discussing about views, window functions, and finally an activity for window functions. Let's get started. So going back to our previous discussion about SQL queries, what queries return whenever we execute them inside of a DBMS is what we call a result set. So these particular result sets, right? These are the rows of data that are returned to us given the queries that we've made and other constraints that we might have applied. In some cases, these result sets might be something that we'd like to query from afterwards. So in those particular situations, let's say your query will be used as an intermediary step for another query later on. And if you want to be able to use that result set from the intermediary query, we can make use of certain kinds of special kinds of SQL queries. And one of them is what we call a derived table. So a derived table is essentially a type of temporary table and can be used to replace some of our source tables in our queries, such as the table names in our from and our join clauses. So in these particular kinds of temporary tables, right, these can be useful when we want to apply some intermediary transformations to our data. For example, let's say we wanted to do an intermediary transformation to our table first, and then afterwards create a query from it. The way that we would do that is through the following sample template of a select query with a derived table. So it still starts with something that we're very familiar with, a select statement, followed by a couple of columns that we want to select. And you'll notice we are using an alias here called DT, referring to a particular table. And this particular table, we're trying to get column C1, C2, etc. Okay. Afterwards, we provide a from clause so that we know what the source table is. And in our case, instead of providing a name for this particular table, we actually provide another query inside, right? So as you'll notice, the from statement is directly followed by a parenthesis pair, and within that parenthesis pair, we have another select statement. Select C1, C2 from an actual database table now, and we might apply some where clauses to that. Okay. After this particular select statement, right, which is the derived table, we provide it with an alias, and we just call that alias dt. Okay, so to demonstrate how it works, let's say we have an example here. Here we're making use of the SQL2 pubs database that were provided from before. And in this particular database, let's say we wanted to know the total price from all books by author, meaning given the authors that we sort of carry in this particular publication house, what is the total price to purchase all of their books? So the statement here is select author name, sum price as total price from book, group by author name, order by total price, descending order. So we're grouping the book table by author name, and we are summing up the prices based on those groupings. And if we execute that piece of code, we will see the following result set, right? We have an author name as well as a total price column, and the values are, for example, G.R.R. Martin, which has a total price of 6,300 pesos for all of his books, followed by Tolkien, which is 1.8K, and so on and so forth. So let's say we wanted to make use of this particular table as an intermediary calculation for another query later on. How would that look like? Here, what we would do is we would essentially copy and paste that particular query and put it in place of a table name in a from clause, right? So that's how we can essentially make use of that previous query and use it as a derived table. So in this particular example, let's say we wanted to know the average of those prices. So instead of creating a query, we can just use the previous result set as a derived table. And in that particular situation, you should notice that here we have our original query from before, right? Select author, name, some price from book, group by author, order by total price, right? And that particular query is now used as a derived table in this outer query, right? The outer query being select the average of dt.total price as average price, right? And you'll notice whenever we refer to anything from the derived table, we have to make use of the alias that we provide for that derived table. The alias for this derived table is called dt, and as such, when we need to get the average of the total price, we have to specify the alias of that particular column. All right. And if you are able to execute this piece of code, you should notice that the result is this particular result set, right? We just have one column for average price and one row, and that value is 1983.9. Next, let's move on to another kind of temporary table, which we call common table expressions. So a select statement with a common table expression is fairly similar to a derived table in the sense that they can be used as temporary tables for a larger query. Often though, CTEs, as what we call common table expressions, they're often better than derived tables when the temporary table that we make use of is used multiple times in a larger query. And personally, I do prefer common table expressions because of how they are structured compared to a derived table, right? So to create a common table expression, we have to make use of a special keyword called with, and this is essentially, it tells SQL to create this common table expression as follows, right? So in this particular example of a select query with a common table expression, we first sort of instantiate this common table expression, right? Similar to how we instantiate variables in Python. Here we instantiate this common table expression using the keyword with, and then the name of the common table expression as, and then after that as, we provide the select statement, right? The query that we will use as the common table expression, right? After essentially defining this variable based on this particular expression, we can then use that particular variable, right, the CTE, in our select queries. So as you notice, directly after the with statement, we proceed to the main query, which is select cte.c1, select cte.c2 from CTE. Again, very similar to a derived table in the sense that we make use of the derived, or rather the common table expressions alias when we refer to any particular columns inside of that head of that common table expression. Okay, and the good thing about nested CTEs is that you can easily nest them a lot easier compared to, let's say, derived tables. So here in this particular example template, we are defining two CTEs. One here, we just specify CTE1 as this particular expression, and we can also define another common table expression called CTE2 as another expression. And the nifty thing about common table expression is that you can actually use CTE from before and reference it in another CTE later on. So as you'll see here with CTE2, we can do select CTE1.c1, CTE1.c2 from CTE, from CTE1, and that particular CTE1 refers to the common table expression from before, right? And given this, also we can do a select cte2.c1, select cte2.c2 from cte2 as our main query as well. So here we will go back to our previous example. Let's say we wanted again to know the total prices for all books from all authors, and then we can use that particular query as the source for our larger query, which is to know the average of those prices. As you'll see here, we essentially still have our original piece of code where we gather we group by our table so that we can group it by author name, and then we get the sum of the prices. We use that as a common table expression, and we call it as this particular variable called dt. Afterwards, we can then proceed to write down our larger query, right? So we can still do select average dt.total price as average price from dt, and we should get the same particular result set as we saw from before. These particular aliases, of course, you can call them whatever that you'd like, right? It doesn't need to be called DT or CTE. Could be A, could be something more descriptive actually. So you can maybe call it total price by author, right? Depends on your use case. Here, for illustrative purposes, we just really we chose a shorter alias. So let's compare how CTEs and derived tables look like. To the left, we have a CTE, and then from the right, we have a derived table. As you can see here, they fairly look very similar because they contain the same temporary table that we have been using from before, right? The difference is that they are placed very differently, right? In the case of the CTE, we notice that the CTE is placed before the main query, right? If this is the CTE, then the next few lines is the main query. While in derived tables, you notice that the derived table is within the major query, right? Or the larger query. So there might be some difficulties with reading code, with reading SQL scripts that make use of derived tables, because you have to be able to identify which are more nested derived tables, right? Because it is possible to create very deep nests of queries by way of derived tables. But at least with CTEs, right, there's no need for you to identify the depth of a particular query, because these subqueries, right, are essentially executed one by one, and you know which subqueries will be executed first, and then second, and finally last, right? So this is why oftentimes it is just a bit easier to make use of ACTE for the programmer's benefit as well. But these two, CTEs and derived tables, they're essentially equivalent.